How a molar, jawbone, and pinkie are rewriting human history. Stunning discoveries and fresh breakthroughs in DNA analysis are changing our understanding of our own evolution and offering a new picture of the other humans that our ancestors met across Europe and Asia. Deep inside Cobra Cave in the remote mountains of northeastern Laos, the beam from Eric Sazzoni's headlamp bounced across barren rock until it flashed on something unusual. Dozens of bones and teeth protruding from a layer of sediment and rock. Sazzoni, a tall 50-year-old caving specialist with a tiger tattoo on his arm, yelled out to his partner, Sebastian Frangel. This was the French explorers' first foray into Cobra Cave. They had just scaled 65 feet of limestone cliff, ascending from the forest floor to the cave's entrance with their unlikely companions, a pair of local teenagers in flip-flops. The Hmong boys knew the terrain around the cave and the namesake cobras that sometimes lurked inside. Today the snakes were nowhere to be seen. But soon after climbing into the cave, the explorers had stumbled upon what appeared to be a trove of ancient fossils. Sazzoni and Frangel were scouting this cave for an international team of paleoanthropologists excavating sites nearby. For more than 15 years, the scientists had been digging in these mountains, searching for clues to some of the deepest mysteries of human evolution. When did Homo sapiens arrive here? And what other humans did they encounter? Sazzoni didn't dare touch the fossils at first. But when he returned to survey the cave the next day with one of the research team's geologists, his task was to pry loose a sample of the sediment from the cave wall. As he tapped on a chisel, a large brown tooth tumbled out, a molar that looked eerily human. Sazzoni hadn't intended to make a find. By protocol and profession that was the scientist's job, but he marveled at the specimen for a moment and slipped it into his shirt pocket. It was, he says, a beautiful gift. Back at base camp, Sazzoni huddled with the research team's leader, paleoanthropologist Fabrice Demeter with the University of Copenhagen, and Clement Zanali, an expert in archaic teeth with the University of Bordeaux. Sazzoni carefully described what he'd seen up in Cobra Cave and showed them a few animal teeth he'd pulled from the sediment. Then he reached for his pocket. "Oh, I brought something for you," Sazzoni said with a grin. Zanali, wearing an Indiana Jones hat, leaned in for a close look. The tooth was completely unworn, well preserved, he remembers. I knew immediately that it was human. But what kind of human? It was too big and rippled, he thought, to have come from a modern Homo sapiens. And though it superficially resembled a Neanderthal tooth, remains of that species had never been definitively identified in East Asia. The scientists exchanged baffled looks. Who was the owner of this mysterious tooth? A molar in Laos, a jawbone on the Tibetan plateau, the fragment of a pinkie in Siberia. Our evolutionary history is now being rewritten by tiny discoveries illuminated by fast-advancing science. Breakthroughs in ancient genetics, the study of proteins, and radioactive dating. The flood of new insights is not only radically changing the understanding of our origins, it is challenging the very notion of what it means to be human. All of us, all 8 billion people on this planet, belong to a single species. We Homo sapiens are the last hominins on Earth. Not long ago, it was widely believed that modern humans followed a relatively straight path of evolutionary progress as we fanned out of Africa, one that was separate from, and implicitly superior to, that of other species. Even today, one of the most indelible images of evolution is the so-called March of Progress. An illustration plastered on t-shirts and posters that shows our predecessors improving their posture as they progress inexorably to Homo sapiens, tall and proud, striding into the future. The current upheaval in evolutionary thinking has shattered that neat linear view of human origins and begun to replace it with a far more tangled picture. What researchers now know is that between 70,000 and 40,000 years ago, a critical period in our evolutionary development, the world teemed with human variety. And as Homo sapiens radiated out across Europe and Asia, they encountered and at times even mated with other types of humans. Evidence of this commingling came in 2010, when Swedish paleogeneticist Svante Pääbo mapped the Neanderthal genome for the first time. His work proved that Neanderthals and Homo sapiens procreated, and that the genetic exchange had profound and lasting consequences. Today, more than 40,000 years after the Neanderthals went extinct, most human beings alive carry remnants of their DNA. But who else shared the planet with us? And how did our interactions with these other humans shape the course of our own evolution and their extinction? Paleoanthropologists are delving ever deeper into these questions, the same ones that Demeter and Zanali faced as they studied their mystery tooth from Cobra Cave. One of the most revealing clues came from a cave in Siberia, near Russia's border with Kazakhstan, where researchers uncovered a pinkie fragment, no larger than a pea. The frigid temperatures in Denisova Cave had preserved ancient DNA in Neanderthal fossils discovered there. But this bone, more than 60,000 years old, was different. When Pabo and his team analyzed its DNA, they came to a stunning realization. The fossil belonged to a completely unknown and vanished human species. The Denisovans, as Pabo's team dubbed them, became the first human group ever identified solely through DNA, a ghost species as experts call those without a physical identity. Denisova Cave yielded more fossils with their DNA. These included a bone from a girl who had a Denisovan father and a Neanderthal mother, the only first-generation hybrid hominin ever discovered. From the finger fragment, geneticists were able to trace Denisovan DNA in modern-day populations all over the world, from Iceland to Peru, with especially high concentrations in Papua New Guinea, 5,500 miles away from Denisova Cave. Homo sapiens almost certainly interbred with Denisovans as well as Neanderthals and carried their DNA across the planet. Paleoanthropologists now believe these gene flow events were not an anomaly but a central feature of evolution, helping Homo sapiens adapt to new environments and leaving most of us with a direct biological link to extinct groups of ancient humans. For all the advances in genetic and protein research, understanding how Denisovan genes made it to Papua New Guinea or why Neanderthals and Denisovans, after nearly 500,000 years of existence, disappeared once Homo sapiens arrived will require more fragments of ancient bones and teeth. After more than a century of digging, the fossil record of our best-known relative Neanderthals is comparatively sparse. Bones from about 400 individuals. The Denisovan record is vanishingly small. All of the Denisovan fossils ever found could fit into a bread box, and there'd still be room for bagels. The consequences of ancient interbreeding are still poorly understood, but geneticists like Huerta Sanchez believe it served a vital evolutionary purpose. Not only did all that mating inject much-needed genetic diversity into Homo sapiens populations, the gene flow gave modern humans evolutionary shortcuts to adapt more quickly to extreme environments, staving off hypoxia in Tibet, for example. This bolstering of the immune system likely helped Homo sapiens spread across the world. But the impact hasn't all been good. Scientists are finding that some of the genes inherited from Neanderthals and Denisovans are associated with depression, autism, or obesity. Interbreeding, moreover, didn't seem to help the Neanderthals and Denisovans. Though remnants of their DNA live on within us, their genomes show no trace of modern humans, and some scientists believe that interbreeding with Homo sapiens may even have hastened their demise. Ludovic Slimak is obsessed with the moment when Homo sapiens might have pushed other human species out of the evolutionary picture. The French paleoanthropologist with the University of Toulouse III has chased the ghosts of Neanderthals from the Horn of Africa to the Arctic Circle. For the past quarter-century, he and his wife, archaeologist Laure Metz, have spent much of their time digging and thinking in Grotte Mandrin, a cave in southern France inhabited at different times more than 42,000 years ago by Homo sapiens and some of the last Neanderthals. It's just a small rock overhang, but the human story it tells is really universal, says Slimak. I use Neanderthals as a mirror to try to see ourselves more clearly. Slimak, bearded and barefoot, is halfway through an animated soliloquy on the Neanderthal extinction when his 7-year-old son bursts into their 12th-century stone house in the foothills of the Pyrenees. "Papa, look what I found." The boy drops a pile of bones onto the kitchen table. Slimak jumps up in delight to inspect the haul. The bones are the remains of a deer, and father and son piece them together into a skeleton. Slimak sees himself reflected in his son. "All my life I've been on a quest for our origins." Slimak's pursuit has led him to study the period when Homo sapiens emerged from Africa, entering territory inhabited by Neanderthals, Denisovans, and other late hominins, the ghost species. This was a critical moment, the 52-year-old believes, when the last of these other humans were carrying out their own experiments in humanity, experiments that he strives to understand not just from a genetic perspective but from a behavioral one too. Scurrying around his office high in the rafters of his medieval home, Slimak shows me stone flints found in Grotte Mandrin. "When you take Neanderthal tools, each is unique," he says, pointing out the variations in shape, color, and size. Living in small, isolated groups across Europe, Neanderthals displayed a creativity and a sensitivity to their environment, quite unlike early Homo sapiens, whose tools and weapons were almost identical from the Levant to Western Europe. Neanderthals, Slimak says, perceived and engaged with the world in ways profoundly different from those of Homo sapiens. The discovery in Grotte Mandrin of one of the last Neanderthals in Europe has prompted Slimak, a National Geographic explorer, to think deeply about how the divergent natures of Homo sapiens and Neanderthals may have led to the latter's ultimate demise. The skeleton, which Slimek named Thorin after the Dwarf King in J.R.R. Tolkien's The Hobbit, was found a decade ago. Slimek's team has been slowly unearthing it ever since, using tweezers to remove grains of sand and fragments of bone. After 9 years, they've recovered parts of Thorin's skull, 31 teeth, and a large number of tiny, unidentified bones.